of Python level 3. And so before we get started with the material, I want to do some introductions because I see a couple of familiar names, but I also see a couple of new students as well, which is great. And so I just want to get to know everyone a little bit. So just really basic name, school, grade, and Python experience. I mean, some of you I've already taught before, so I know, but especially for the newer students that I haven't seen, I'd love to know how you feel about Python. Do you feel rusty? Do you want more review? Things like that. I'll go first. So my name is Jack, and I'm currently a college student at the University of Virginia. It's my third year there. I'm studying computer science and math. And my programming experience really started in high school and just got into it, creating random projects, and I really found an interest. So I just continued into it, and that's what I'm studying as well. And I'm really excited to be your teacher for the next 8 weeks, I think. And yeah, that's it for me. So if anyone would like to volunteer, happy to go in any order, or I can also just go down the list of participants, whichever is easiest.
Mom!
Oh. All right, let's just go down the list. So first off, Alex Wu, can you introduce yourself a little bit?
Hi, my name's Alex. I go to Kent Gardens. I'm in 6th grade, and my Python I learned from you for Python 1 and 2 like last year or something.
Oh yeah, I do remember that. And I think I taught CAD as well. Is that right?
Oh yeah, you taught me CADs 1, 2, and yeah, that's it.
It's great to see you back. All right, Derek?
Hi, my name is Derek. I go to Sunset Ridge. I'm in 5th grade and I've taken some of your classes.
Yes, I do remember you, and I'm happy to see you here as well. Esther?
Hi, I'm Esther. I go to Poseville High School and I'm in 9th grade. I've done this class before.
Yep, I remember you too. Awesome. Evan?
Hi, my name is Evan, and I've been in Python 1 and 2. I've also had an interest in programming. Started learning it in 3rd grade, and I'm from John Paul Middle School, 6th grade, and that's it.
Cool. Good to see you back, Evan. Jarrett, would you want to go next?
Yeah, okay. My name is Jarrett. I go to Urbana Elementary. I'm in 5th grade, and I've been taught by Jack in Python 1 and 2.
Yep, I had a lot of fun with that. And last but not least, Wintian, do you want to go? I see you unmuted, but I can't hear anything.
Oh. Hi, I am Winchin Wang. Right now, I am 11 years old, and I am in 6th grade. And I know a little bit about Python, but I'm not really that good at it. And I've never taken your class before.
Yep, that's completely great. But I'm glad that you're here today, and it's really great to see some of you returning from just 2 weeks ago, some of you returning a little bit longer ago, and some new people as well. We're gonna go over a basic review of Python because I know we all forget things, and I want to make sure we start off with some common ground to build off of. Anything? Yeah, that's all I had for introductions. It's always interesting to see where everyone comes from, and really impressed at all of you. So I guess this is just something I want to get done in the background. So I think hopefully everyone has PyCharm installed. If not, please let me know. But if you do, just launch it up right now. You don't have to do anything after starting it up. It's just, I know it takes a little bit, so I want to make sure it's ready when we need it.
Wait, will VS Code work? Because I don't have PyCharm.
Yeah, if you feel more comfortable with VS Code, perfectly fine. We're not using anything that is specific to PyCharm. Yeah. Okay. So starting off with just a really quick review of Python 1 and 2. I'm gonna skip some of it, like how to create a variable and how to like add two numbers together. But there are some more key points that I want to point out. Make sure we just remember and just make sure we get familiar with it again. And so the first thing was kind of working with strings. And when we first learned strings, we also learned a couple important ideas called indexing and slicing. And we saw those were useful in other things as well, like lists in Python also use indexing and slicing. But really quickly, I have a quick question about strings. What does an index of -1 mean? And so I have this example, and I have a string Python level 2 class. I guess this should be updated to Python level 3 class. But if we print out x at index -1, yes, we get s, the last letter. Also, I should make this clear. Feel free to contribute or speak up however you feel comfortable. If you want to unmute, perfectly happy with that. And in fact, that's maybe my preferred because it's a little bit more fun to hear everyone talk. But if you want to use the chat as well, I do have it open and I do keep an eye on it. So if you have any questions, feel free to speak up or put in chat anytime. I don't mind. You're not interrupting me in any way. Yeah. So yeah, indexing is just, you have positive indexes. The thing to remember is it starts at 0 and goes 1, 2, 3, 4 after that. And the special thing about Python is that it has negative indexing. So this is not, it's not in all programming languages, but in Python they have it and it's very useful sometimes. In particular, -1 is used a lot to get the last element. And like I said, this applies to not just strings, but also lists. And so I don't have a slide on lists, but lists in Python were a data structure that we learned. And it allows us to basically keep track of a bunch of individual variables all in one kind of container. So instead of having to manage like 10 different variables, instead we just manage a single list that stores all the variables for us. And once we have this list, we can just index into it to get a specific value out of it. There are other things that we talked about, such as a list can grow as big as you want. So you can create a list with 5 elements and then you can just keep adding to it. It can grow however big you want. You can remove things. They don't have to be the same type. So you can have a list that has a string and a number in the list at the same time. And that's not always the case in all programming languages, but that's something that Python supports. I think we're gonna see slicing a little bit later, so I'm gonna hold off on that. This is not a question, but rather just another thing I wanna bring up, user input. We might see this a little bit in our Python 3 material, but just a quick reminder, if you want to prompt the user, so if you have a program and someone's running it, and you want to ask them for some sort of input, maybe you want them to type in a word or have them type in a number, anything like that, you want to use this input function. And so this input function, you give it a string, and it's kind of just a message for the user. So it'll print that out and say, please type in something, and then it'll just wait until someone types in and hits enter. And once it does, your program resumes again. It takes that, stores it into a variable, and then you can use it just like any other variable. There was something that we talked about that was something you should keep in mind whenever you're using the input function, especially when you're, say, asking someone to type in a number. What is the thing that we have to remember when we're doing something like that, when we're using the input function? So if I had a code like, please type in a number, right? And I'm expecting them to type in like 5 or something like that. And I want to do print, I don't know, x squared. So I want to take whatever they took, I want to take whatever they typed in and I want to get the square of it, multiply it by itself. There's something that is gonna break if I try to run this code. What's gonna happen? Evan, do you remember what might go wrong if we try to run this program?
Because you put in 2 times. But also if you type in a little letter, right, the syntax error or something.
Yeah, I think you're getting to the right point. So this double times, this is fine, actually. This was, it was a while ago, so don't worry if you don't remember. This is a shorthand for exponentiation. So if you want to do something to the power of another number, so 3 to the power of 4 would look something like 3 times 4. It's not like this that you might see in maybe my math class. Python has double times. But what you did say, the second part is correct. What happens if someone types in a letter? And actually, even if someone types in a number to this, it is still gonna break. So even if I type in like 10, it's still gonna break. And maybe I can show that really quick. So if I go, don't worry about this, this is just my PyCharm, but if I make a new file and try to run this code that I have, paste it in, I have to deal with some formatting things, and let me make text a little bit bigger. So if I try to run this, you can see at the bottom, this is my prompt. Please type in a number. And if I type in 10, which looks like a number, I'm still gonna get an error. And so what's going on here? Maybe some of you guys remember now after seeing this. This is a big hint. Yeah, exactly. I like your revelation there, Evan. Yeah, so the input function always takes in the input as a string because you kind of have no idea of what the user is going to type. You ask them for a number, but that's just a message. They can type in whatever they want. And so this input function has to handle that somehow. And the way it does it is it just takes in whatever they typed as a string, no matter what they typed, right? It doesn't do any, it doesn't look at it and say, oh, this looks like a number, so I'm going to store it as a number. Or this looks like a decimal value, so I'm going to store it as a double. It just says, I'm going to put it into a string. And so after this line, X is a string. And to get it to a number, you need to do something like that's suggested in chat. Maybe like num equals int X. And you need to use this int function to convert it to an integer. And then after that, now you can do this. And so if I run it again, and now if I type in 10, now it does work. It gives me 100, which is 10 times 10. It's a minor thing, but again, I think what's important to remember from this is types matter in Python. So we have strings, we have ints, we have doubles, we have lists are a type. We're gonna see a lot more complex types coming up. But you kind of have to be careful of it, even though in Python, you don't have to say what type things are. So when I create a variable X here, I don't have to say what type it is. Python will choose it for me. It will take care of it. but you do have to understand what's going on, or else you might run into some issues where it's, hey, this isn't the type I was expecting. I was expecting this to be a number, but it's a string. Well, why is that? You have to understand what's going on behind the scenes to do that. But that was kind of a quick overview of the basic commands. The next thing we covered were these control structures. So how to make your code not just run in top down and that's it, but we learned how to do loops where you can repeat certain commands over and over again. And so this, for example, if we look at this code, this actually doesn't do anything interesting. Actually, this might not even work, but if I do something like this, and we be more interesting. So here we have x equals the input. And so this is using the user input again. I get some sort of sentence, I can assume. And now I say for a in x dot split, I'm gonna print a and then this weird colons thing with a -1. Yeah, I did change it. So what's going on here? Well, this is one type of loop that we covered, a for loop. And this is a for loop. And how it works is you have to have some sort of list, some sort of thing we call an iterable, basically some sort of container that has a bunch of elements in it. And here, the container that we're using is the result of calling x.split. So again, x is what we got from the user input. Dot split just basically takes a string and chops it up. And by default, it chops it up wherever the spaces are. And so this is going to give us a list of the words in whatever we typed. And then this for loop is going to say, okay, so for everything in that list, I'm going to do some sort of operation on it. And the way I do it is I have to have some sort of temporary variable name. So here it's going to be called a. I could have called this whatever I want. And inside the loop, this variable a is going to take on every single value that was in my list. And so it's going to become every single word in whatever sentence I typed. And then inside, what we do is a bracket colon -1 close bracket. And so this is an example of slicing. And so slicing is like you give it a start and a stop, and then you can also give it a step. And so when you don't give like a real value here, when you just have it empty, it takes on some default values. So the default is you start at the beginning, you end at the end, and -1 means that we're stepping backwards. So this is going to take a sentence, cut it up into every word, and then for each word, it's going to reverse the letters of it. At least hopefully that's what I hope this is gonna do. And so if we just run it and test it out, we can see, I don't know, hello class, nice to meet you. And so you can see, maybe if I move it around a little bit, it does what we wanted it to. And so here's my input. It chopped it up into each word. Hello class, nice to meet you with the exclamation mark. And for each of them, it just reversed the string and printed it out. Okay. So this is an example of loops. And a really quick question to you guys. There's another type of loop that we've covered. And does anyone remember what it was called or the keyword that we used with it? Yep, thank you, Derek. A while loop. So a while loop is the other type of loop that we've seen, and that works similarly. So it also allows us to repeat commands. But a while loop works differently in that it takes a condition. It's the loop condition. And essentially how a while loop works is that as long as that condition is true, it's going to keep looping. As soon as that condition becomes false, it will stop. And it only checks it at the end of each loop body. And so generally, while loops are very useful when you maybe don't know how many times you need to loop. While a for loop, if you know I want to do this 10 times, you're going to use a for loop most likely for it. You can use both in any case, but sometimes it's just easier to do one over another. Yeah, so for loops, while loops, those are two loops that we've seen. Code flow. So another way we can control how the code works is with these if, else branching statements. And they basically take our flow of the code and based on a condition or multiple conditions, it will decide what to do. So it'll only do one of them, but it will choose based on whatever you tell it to choose off of. So the way it works is you say if, and then you have some sort of condition. And the condition is a Boolean value. It's going to be true or it's going to be false. You don't have to say true or false. It can be a variable that is calculated somehow above, but it's just going to be some sort of Boolean value. If it's true, you're going to do whatever's in the body, right? Once you do whatever in the body, you're going to skip everything else part of this kind of structure, right? You're not going to bother with the else if, you're not going to bother with the else. You're just going to jump to whatever's after this. We don't have anything here, but if there is, you jump there. On the other hand, if you check the if condition and it's not true, then you might jump to an else if statement. So ELIF is short for else if. And you just have another condition that you want to check. So, okay, the first one wasn't true. Let me check the second condition. And if the second condition is true, okay, then I'm going to do whatever is in this body. And once I'm done, I'm going to jump to the end of this whole statement block. And I'm going to jump to whatever's here. Or actually whatever's at the bottom of this slide, I guess. And finally, you can have as many else ifs that you want. I only had one here, but you could have 10 of them. You could have 0 of them. And then at the end, you have an optional else that you can put. And basically, if nothing above worked, if none of the above conditions were true, I'm just going to go to the else and do whatever's there, right? And so this is a way of doing kind of, if you know a flow chart, it's like, okay, is X greater than 10? If it is, I'm going to do this. If is X greater than 5? Okay, then I'm going to do this. Otherwise, okay, then here's my default case or whatever. So once we covered that, I just have, I think, 3 more review slides before we'll get into the hopefully a little bit more interesting things. But here's where we get to Python level 2 material. So here we're done with basic commands, we're done with code flow, and now we're doing kind of organization ideas. So the first thing that we saw was functions, organizing Python statements, Python commands into a block that we call the function. And a function just defines some amount of code that we can use in a bunch of different places later on. And we talked about why you should not copy paste code, because it makes your code larger, it makes it harder to read, and it makes it harder to maintain. If you find an error, it's really hard if you copied the code 10 different places, right? You'd rather want to write it once and then just use it. You just want to reference what you already wrote instead of writing it again. Okay? And so here is how we define a function. You have a def keyword, function name, parentheses with your function parameters, and then you can have a function body. And once you define a function, you can call it just by the name of it. So add number 1020 is going to call this function. It's going to pass 10 into this parameter variable. It's going to pass 20 into the second variable, and it's going to return or give you a value of 10 plus 20 or 30 in this case. We saw a lot more complex functions in this. You can do a lot more interesting things, but I just want to make sure everyone is reminded of functions, because we're going to see better examples later on. And really the last important thing I want to review is the idea of classes. And I know we spent a lot of time on this in Python 2, and it was definitely the hardest material that we covered. And if you don't feel 100% comfortable, hopefully Python 3 will strengthen that a little bit, because we're going to be working with a bunch of different classes. And so really practice is what builds confidence and makes you more comfortable. But the two really things, or really three things I want people to remember from classes is that one, what do they contain? They contain fields and methods. So fields are just variables, right? Just pieces of data. And these variables can store whatever they want. We call them fields in a class. Then we have the methods, which are it's just a name for functions. So a class will have a bunch of methods defined in it. And they're just things that the class knows how to do. And so that's what makes up a class. The next thing I want you to remember is that classes, what do we do with them? We use them to create objects. And so the objects are actually what we interact with most of the time. And so the class is more like this idea of something, and it's important and we have to define it. But once we define it, what we're really going to do at the end is take that class, turn it into like a factory that produces objects. And these objects are what we use to call the methods, or what we actually play around with in our code. And finally, there was this idea of inheritance. And so does anyone want to try to explain what inheritance is, and very basically in classes? Okay, Derek, I see you have your hand raised.
You get something from one class and then you make another class that has some same properties.
Yeah, that's a great way to put it. So inheritance is kind of what it sounds like. You have a parent class in this case, and you have a child class. And the child inherits things from the parent. And specifically, it inherits everything that we said here, right? Anything in the parent, it will be passed down to the child as well. And again, this is one way of allowing us to not repeat ourselves. If we have some sort of code in a class that's really useful, and we want to define kind of a more specific version of that class. So maybe the example that we talked about in Python 2 is you might have a vehicle class that defines how, like, has methods like turn on or accelerate, decelerate, things like that. But then maybe you want to make a class that defines what cars are, or what trucks are, or what motorcycles are. All of these things share some sort of common things. They all share the things that all vehicles do, right? They do have some differences as well, but they have their similarities. And the inheritance structure allows us to basically take all the common aspects of all those separate like classes, the car, the truck, the motorcycle, put them into a parent class, and then we can inherit to define our car class, or truck class, or motorcycle class. And it's important that when you inherit, just because you inherit everything from your parent doesn't mean that you're an exact copy. Typically what we do is we inherit and then we add more to it. That's why we use inheritance. We define kind of additional features. That's really the important thing I wanted to cover for a review of Python 1 and 2. I have one last slide talking about modules and packages. This is something we covered very briefly at the end, and it's going to be a little bit important today, but is not too necessary. We have modules and packages. The important thing to know is that modules equals files. So whenever you write a Python file, that's also a Python module, right? Packages are just kind of one level up. Packages contain other modules, and Python packages can also contain other packages. So you can have a package inside of a package that has a module in it, things like that. You can also think of packages as like folders, right? If you think of it as the file analogy. So a package is just a folder, and you can put folders inside of folders, inside of folders, inside of folders, and then maybe you have a file at the very end. Right? That's a module. The reason this is important is because we are going to install another thing, but luckily this is going to be very easy to install. Pygame is a set of Python modules that we're going to install that allow us to create video games. And in case you didn't know, the goal of this Python level 3 class is to introduce you to this library. And hopefully at some point, you'll be able to make your own games and you'll be able to go off and do whatever you want with it. So it's going to be a little bit more open-ended as well. But for now, we're just going to learn what it is, how to use it first. And so it's just a set of Python modules. It's all assembled inside a package, things like that. And it really helps us deal with computer graphics, sound, and it kind of makes things easy for us in the sense that it takes care of the details, so we don't have to focus on how to like move the pixels or whatever, but we can focus more on the bigger level of, okay, I have this enemy that I want to move back and forth, right? And things like that. I guess before I move on to the actual installation stuff, I was wondering if anyone had questions about the review section of Python 1 and Python 2. Anything that we covered so far that maybe didn't make sense or you want a little bit more, want me to talk a little bit more about? I can't hear anyone. So, okay, so I see some thumbs up as well. So I'm going to move on for now, but as a reminder, if there's anything while we're coding that doesn't make sense, you don't know what's going on, please just put a message or speak up, or you can always email me outside of class as well. But I think the sooner we resolve it, the better it is, because as it always is, we're building on top of what we're doing. And I just want to make sure that we don't, go too fast. But if that's the case, we're gonna start looking into Pygame a little bit. And let's see, yeah, the rest of today's class is going to be installing and just playing around, seeing what's there. And then we're gonna go deeper next week. So there's a couple of links here. I'm gonna show off all of these on my share screen, but the main page doesn't have it's not too interesting, but it has some like news and updates, and there's actually like games that other people have made that they've uploaded. But the most interesting thing is the getting started page, which shows you how to do installation, but I'll also go over this as well. And the documentation page, which is going to look very scary at first, but we're going to take a look at this today as well. So let me go back to my slides. So actually, let's go through the installation process. And the way this works is, again, Pygame is a set of modules and packages that someone else already wrote. They're Python packages, and we just need to install it, and just all we're doing is essentially just downloading Python files. And then also telling Python, hey, we downloaded these files, you can look in here and make sure you know what's going on here so I can use them in my projects, right? And so actually to install this, we're not gonna really download anything ourselves. We're gonna use a tool to download it for us. And so that might look a little bit confusing at first, but it's actually not that bad. So if you're using PyCharm, well, we're not gonna be hacking, but it might look like hacking. But here, I'm gonna be showing how to do it in PyCharm, but it's probably gonna be very similar in VS Code. But if you're having trouble with installing it because you're not sure how to use VS Code, let me know, and I'd be happy to help as well. But what we want to do first is get access to a terminal. And so in PyCharm, it's built in at the bottom. You can see there's kind of these tabs, and there's the first one is called the terminal. And you should see something that looks kind of like this. I have my project, or actually, if you're using PyCharm, if you want, you can create a new project for this class. Or if you want to use the same project as Python 2, that's also fine. But if you want to make a new project, the reminder is file, new project. It's going to be pure Python by default, and that's what we want. And you can tell it where you want to put the project. And there's going to be some default space. You can change untitled to whatever you want. And you don't have to mess with any of the settings here. So all the defaults are fine. But you can choose where you want to put it and just hit create. And it's going to take a little bit to load everything. But then you should have a fresh new project. I just created a new one for this class, so I'm not going to do that again, but you just hit the create button and it does all the magic for you. But once you create a new project, now is where the terminal takes place. So you want to click the terminal tab and you should see something that looks like this. You're going to see basically where you created the project. And I created the project in a bunch of folders. So I have this giant thing here, but it's probably going to look a little bit smaller for you. And then you just have a blinking cursor waiting for you to type a command. And the command that we're going to type is called pip. And pip stands for Python, package installer for Python. And it's just a tool that we downloaded when we downloaded Python. And it just is a tool that automatically installs packages for us. And so we're going to use it to install Pygame. So we say pip, we put a space, and then we say install, and then another space, and now we want to say Pygame. Right? So this command, we're using pip, the Python, the package installer for Python. We're telling it to install something. And what are we installing? We're installing Pygame. And once you type that, you can hit enter, and it should start thinking for a little bit. I'm going to see the message. Oops, I should not scroll like that. Let me just make this a little bit bigger. And so it's saying, it basically tries to download it from the internet. So you do need internet connection. It downloads it from the internet. It's going to basically collect everything and start running some stuff to actually install it into Python. And for me, I didn't see any progress bars or anything, but then it just said successfully installed Pygame version 2.1.2. And if this is what you see at the end, that's perfect. And hopefully you don't get any crazy error messages. But yes, Evan, that's correct. Pip install Pygame. Yeah, that's the command that you want to put. One small comment while we're waiting for this is that in PyCharm, at least, by default, it creates something called a virtual environment. And also, Alex, when you downloaded Pygame, you did it in your computer's terminal. That's perfectly fine. So I was using the terminal in PyCharm, but any terminal works. So if you used it in like the default, like CMD, something like that. Oh, my computer is a little bit slow. It's not loading. Okay. Also, if you did it last year, it should also work. But we're gonna create a sample program, and if it doesn't work, we can troubleshoot. But yeah, if you installed it in the past, it should be there still. But yeah, so just a side note is that in PyCharm, you're automatically given this virtual environment. And what this means is like when we're installing this package, where does it actually get like stored, right? When we create this thing called a virtual environment, it basically creates like another copy of the Python program. right? And so it creates a whole new copy just for whatever project that you're working on. And when you install a package using pip, and when you say pip install Pygame, it basically installs it to that copy of Python that you made for this project specifically. And so that means if you create a new project, Pygame's not going to be installed there because it's a different like copy of Python. If you didn't have a virtual environment, essentially what happens is it installs it into the base Python thing that you downloaded when you first installed Python. And that just means that now everywhere it's going to be installed. And so sometimes you want it everywhere, sometimes you don't. But really it's not that important because you can always uninstall it as well. You can always say pip uninstall Pygame if you want to get rid of it. But we're going to use it for this class, so I'm not going to do that now. Yeah, so a really quick way of testing if this installation worked is I'm going to give, is it here? So here's some code that you can just copy paste into your editor. And so I'm gonna, for example, create a new Python file. And I'm gonna say, I don't know, I'll call it first class because it's our first class together. And this isn't really gonna do anything interesting. But the idea of this one is that if you right click and run, if you get a black screen, that means everything's working, right? If you get error messages, then that means something didn't work with the installation. And so at this point, I want to kind of just pause a little bit, see if anyone had any issues with installing, see if people are able to get this window to pop up. So Evan said nothing worked. Okay, so I think the best way to do this is if you're able to share your screen, Evan, I can try to troubleshoot with you. No command called pip. That's a little bit interesting. Evan, are you able to share your screen? Also, did anyone else have any issues installing it? All right, no problem. Alex, yours worked great. Jarek, I think I saw that you said it worked. Esther, Jarrett, Wentian, did it work? Or Jarrett, yes?
It worked.
Nice. Esther, did you get the window to pop up? Nice. All right. So I'm glad because installation can always be a little bit tricky. But it looks like it worked well for everyone here, and hopefully I'll be able to troubleshoot with Evan later. But now that we have it installed, let's see, we have 15 minutes. We can start one thing. Let's do a program that looks slightly more interesting than just a black screen. It's still not going to be super interesting. It's still going to be very basic, but it's going to be a little bit more fun to look at, I guess. And so here's the Pygame page again. And I think I'm going to give this page to you guys. It's gonna be a little bit, I think, a lot of learning at the beginning, because we just have to figure out how this package, how all these modules work together. But once we get through this, you're really just gonna have a bunch of tools to do whatever you want. And so I think that's the most fun part, but there is some stuff that we have to get through first. But here is, if you click on the link that I put into chat, this is like a introduction program. And so you can copy paste this code. And if you try to run it now, it's gonna break because it's expecting, you can see this line 10, it's trying to load some sort of image called intro ball GIF. And to make that work, you can download this picture right here actually. So if you like right click and save image as, it's going to save the intro ball.gif file. And so you want to basically go wherever your code is located and save the file there. If you don't know where your stuff is located, one way to figure out really quickly is that if you're in PyCharm and you just find, here's my project, AOE Python 3, I can right click it and I can say, should be kind of towards the middle, show in Explorer, and it will open up where the folder is in my like file explorer. So I can see, oh, it's located here and my code is here. Another way you can do it is actually, you can just drag this picture into the file explorer. So like maybe another way to make it easier is if you open it side by side, you can just drag the file in and it'll download it automatically. That's another trick. But once you have the image file and the code, there's one last thing you might want to do is you want to make the screen a little bit bigger, the size and the width. So maybe something like 1000 and 800. And if we run this now, you'll see just a ball bouncing around. So slightly more interesting than just a black screen. Now we have a little bit of movement, but this gets you an idea of what we're gonna be doing. We're basically, how we're gonna work with this library is that we're gonna create a window, and that's gonna be like our canvas. Like we're an artist and we have a canvas and we're gonna start drawing things onto it. We can draw sprites onto it. So we have this ball image. We are able to take that image and draw it onto our screen. But we're also gonna be able to add some logic to our game. So here, there's some logic controlling how the ball moves and what happens when it hits a boundary. And if you wanna know how this program works, the same page that I had you download the code from has a very, very in-depth like discussion of how this all works. So it says on line 8, we create the screen. On line 10, we load the ball. On, I don't know where it says line 11, but we get like a rectangle, the bounding box of it. And then we have some sort of loop, and it just really goes in depth of what this short program is doing. But we're gonna see a lot more interesting things to this. But hopefully it's starting to be a little bit more fun. The thing I want to go through probably until the end of today's class is introducing you guys to the idea of documentation. So whenever you start using a new library, there's so many things in here that we just don't know how they work, right? So someone wrote all the modules, all the packages, but we don't really know what's there yet. And so how do we find out? We can look online, but we can also look at documentation. And I see some message in chat about history. Yes, I guess there's an interesting history that you can read about. They have a lot of stuff on their page you can explore. But what we're gonna look at is the reference index. And here, this looks very intimidating. So here's one page, the index, but there's also just the documentation page here. So there's 2 of them. Actually, if we look at the second link that I put, so the one on the bottom, this is our like home documentation page. And at the top, you see this bar of basically what they consider the most useful stuff, and then some more advanced things, and some other miscellaneous things that they document. And you can really click on these to get a good idea. And the other link that I sent is this reference index. And this is just a giant list of basically everything in this package, in this library. And of course, I'm not gonna say, oh, homework for this week is to read every single page here. Like that's not what you do with documentation. You don't just sit through and just read every single sentence here, but we're really gonna take advantage of this documentation to understand how we can use this package to do whatever we want. And for example, let's look at one page. So if we look at the code that we had, let's maybe try to look at this get rect function. So in my index, I can try to say get, is it underscore rect? And so you can see here's a link to it, get rect. And when we click on it, we are brought to kind of this page, get rect. And you can see it's under this image class, actually. So here we have an image class, and here is a method of that class, get rectangle. And unfortunately, documentation can be a little bit hit or miss. But here it says, get the rectangular image, get the rectangular area of the image. And here is some sort of notation that kind of describe what's going on here. We have this function get rect, and then it has a return value of a rect, R-E-C-T, with a capital R. You can try to search for examples, but let's dig into this a little bit more. Whenever we see a capital letter, that typically means a class. So this is returning an object of the rect class. So if we go back to maybe our documentation page, whichever one we want, you'll actually see in the most useful stuff, there's a rect class right here, or there's a rect page. If you're in the index, let's try to go back to the index. You can also just Control F rect, and it's actually not going to be super easy, but if we go to the R section, PQR, you can see rect class in Pygame. And so if you click that, whichever one you want, you'll be brought to the documentation for the class. And so this is a Pygame object for storing rectangular coordinates. These are some constructors. So if we just try to understand what's going on, it's not too crazy. You can give it 4 numbers and it will a left top with height, and it'll create a rectangle. You can also, seems like you can give it as a tuple. So left top as a tuple and with height as a tuple. That's another way it supports a constructor. And this other one is a little bit more confusing, but maybe it's not super useful for us right now. But now we can see a whole bunch of functions in here, and it talks about all about rects. So it uses it to store and manipulate rectangular areas, blah, 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 blah. Again, the point of documentation is not always to just read everything here. There's a lot of good information, but sometimes the problem is there's too much good information. And so part of this class, I think, is going to be getting a little bit more comfortable reading documentation, going through this and just going through the discovery process. And because the main idea is that Pygame is just one package that's out there. There's all sorts of packages for all sorts of things that people have written in Python, and they all have their own documentation. And so once you have the ability to go through documentation and get an idea of what's there and be able to transform that into something that you can create using that library, that's really, I think, the goal of this class. But you can see there's all sorts of different things in here. So maybe, looks like, let's look at this inflate method. Grow or shrink the rectangle size, takes an XY value, and it says returns a new rectangle with the size changed by the given offset. The rectangle remains centered around its current center. Negative values will shrink it. So maybe if we play around with this code, let's stop it. Maybe if I say ball rect equals ball rect dot inflate, let's make it, I don't know, 10 pixels larger in both directions for no particular reason. And run it again. Hopefully what we're gonna see, well, actually it gets a little bit stuck now. Why that happens. Okay, let's actually deflate it because fixing that is gonna be a little bit annoying. But you can see maybe now, or let's do a little bit more extreme. But this changes the bounding box of our ball. And so now, if you look at it, it's kind of overlapping with the edge a little bit. The bounding box has kind of shrunk. And so we took something from documentation, we played around with it, and now we can see the effects of it in our code. Yeah, so there's no homework for this week, but I would recommend, if you have the time, to take it around, look through some of these pages. I think the introduction to Byte Game might be a good page to look at. So like the code that we saw for the bouncing ball, maybe try to read through it and see it, get an idea of what's going on. Another thing that you can do is play around with the code here. So it looks like there's a speed variable. What happens if I change this to 4-2? What happens? Well, let me just try it. Let me just run it. And now you can see, one, it's moving a lot, it's moving faster, but you can also see it's moving a lot more in the X direction than it is in the Y direction, right? It's going back and forth a lot more than it is going up and down. And if I make it more extreme, like, I don't know, 40, you can go a little bit crazy. You can see it's gonna be bouncing really, really fast. So that's another way you can play around with the code, see if you can get anything interesting showing up. Maybe look through this logic, but we're really gonna dive into Pygame into next week, and really that's what Python 3 is all about. And yeah, that's all I had for material. There's some administrative things. We do have a Google Classroom, and I think some people are in already, but yep. We have a code to join, and so I put that in chat. So if you go to Google Classroom and insert this code, you'll join the class, and I'll be posting materials and review. You can also contact me through Google Classroom. You can also contact me through email. So oh, yeah. Yep, I think everyone should have gotten an email already from Ms. He about how to join. But yeah, make sure you join here, because this is where I'm going to keep in touch with you outside of class mostly. But again, if you want to email me directly, I put it into chat as well. Feel free. And yeah, we're not going to have homework, like I said, formally this week. But I do encourage you to play around a little bit. We're going to pick up next week where we left off.